Good morning and welcome to our lesson today on developing a formal method for simultaneous equations. So today we're going to be working without the bars. You can see an example on your screen here. 6x add 3y equals 30, 2x add 3y equals 18. So first of all, we've got to decide whether we're doing difference or whether we're doing cancel and sum. Now, for us to be able to do cancel and sum, we're going to need a variable with different signs, so a positive and a negative. And that's not what we've got here. So here we're going to do difference. And for this example here, we've got the same number of y's. So no need to do any multiplying. We can straight away look at the difference between these equations. Now, difference, of course, means subtract. So for the formal method, you're going to subtract one equation from the other. When you're doing the bars, you're just sort of looking at which part of the bar is longer and so on. But here we're going to subtract. So you'll notice I've labelled my equations here, equation 1 and equation 2. And that's so that I can easily communicate what exactly it is that I'm doing. So here I'm going to subtract equation 2 from equation 1. So I've written equation 1, subtract equation 2. And this is equation 1, this is equation 2. So 6x subtract 2x will give me 4x. 3y subtract 3y, well, I'm left with nothing. And 30 subtract 18 will give me 12. So at this point, this is where, if we'd been drawing out the bars, we would have looked at the differences between them. And you can still approach it in that way. So now I'm solving this equation. I'm dividing by 4, which gives me x equals 3. So had we been using the bars, at this point we would have redrawn one of our equations and replaced our x tile with 3's. We're not going to do that though, we're going to do it in a formal algebraic way. So I'm going to select one of my equations and I've gone for equation 1, but it could easily just as well have been equation 2. And I'm going to say, okay, instead of 6x, I've got 6 lots of 3 then. So 6 lots of 3, add 3y is equal to 30. 6 multiplied by 3 is 18. And then I'm going to subtract 18 from both sides to give me 3y equals 12 and divide through by 3. So there's my solution. I've got the solution is x is equal to 3, y is equal to 4. Okay, so let's move on and look at one that involves using cancel and sum. So here we are, we have got two equations where if I look at my y variable, one is negative and one is positive. At the moment, though, they don't have the same magnitude. I've not got the same coefficient in front of my y, but I am going to use cancel and sum. But I'm going to have to multiply so that I've got a negative 6y in this top equation. So I am calling my equations number 1 and number 2, and I'm going to show what I'm doing by multiplying equation 1 by 2. And that will give me 4x subtract 6y equal to negative 30. So I've multiplied all the way through by 2. And I've relabeled that equation 3. It's now a new equation. It's my third equation. This one, though, hasn't changed at all. So this is still equation 2. And cancel and sum. Well, the clue is in the word sum there. For this, I'm going to add my two equations together. So at this point, that's what we were doing with our bar model. We were looking at what we had in total and creating a zero pair between the negative 6x and the positive negative 6y and the positive 6y. So if I add these two equations together, I'm going to get 6x. My negative 6y and positive 6y will create a zero pair. And then negative 30 and 48 will give me a total of 18. Now I can solve that, divide through by 6 to give me x equals 3. And now I'm on to the substitution. So select one of my equations to substitute into. Now I've gone for equation 2. I could have done equation 1, but the reason I've gone for equation 2, I've selected this one, is because there are no negatives all the way through, which means that my job of solving this is going to be just a little bit easier. I'm less likely to make a mistake with my signs. So instead of 2x, I've got 2 lots of 3. Add 6y is equal to 48. I've subtracted then 6 from both sides, and now I can divide through by 6. So y is equal to 7. So my solution is x equals 3, y is equal to 7. Okay, next version here. So just to talk you through, and then I'm going to give you a chance to have a go. I have got a positive amount of y and a negative amount of y. So this looks like I'm going to want to use cancel and sum. However, I'm going to have to multiply both equations to get the same number of, or the same magnitude of y's here. So that's what you're going to need to do first. So what I'd like you to do is have a go at doing this, see if you can replicate the formal working that I did on the last few examples. I've labelled the equations 1 and 2, so you can use that to really communicate what it is you're doing at each stage. So pause the video and see if you can show me the formal working for this pair of equations. Okay, so first of all, we need to get the same magnitude of y's. Now, I need to think about my lowest common multiple for 6 and 7, which is 42. So this first equation, I'm going to need to multiply 3 by 7, and the second equation, I'm going to need to multiply 3 by 6. So that's what I've done right here, and I've communicated it on the side, equation 1 multiplied by 7, and I've then called that equation 3. Equation 2 multiplied by 6, and I've then called that equation 4. So now I can sum, and I'll be able to create my zero pair with my positive 42 and negative 42y. So 21x and 12x makes a total of 33x. And then I've got 336, and negative 72 gives me 264. So final step to find x, then I'm going to need to divide both sides by 33, and that gives me x equals 8. Right, substituting back in, I'm going to select equation 1, and the reason for that is it has no negatives. It's going to make my calculation easier. So I've got 3 lots of x, 3 lots of 8, add 6y equals 48. 3 lots of 8 is 24. So I'm going to subtract that away, and that also gives me 6y equals 24, and then divide by 6, which gives me 4. So my solution is x equals 8, y equals 4. Okay, next example, and again, you're going to have a go at this just to talk you through all of my x's. My x's are both positive, my y's are both positive. So within the x's, if they have the same sign, and then within the y's, if they have the same sign, that is going to be difference. Now here you could make your x's the same, you could make your y's the same. It doesn't actually matter. So I'm going to leave it to you to choose, you to decide. Can you have a go at writing down the formal method with every little step that you take explained as I've done in the last few examples? So pause the video and give this one a go. Okay, so here I have gone for making the x variable the same. It could have been y's. Now, if you did y's, that's fine. Follow through the working that I've done with making the x's the same, and you should find that you'd come out with the same answer anyway. So I've multiplied equation 1 by 2 and equation 2 by 5, and then I've relabeled those equation 3 and equation 4. So now this time I'm looking at the difference. Now what you notice here is that the smallest amount of y is in the first equation. And I can do 4y subtract 15y, but it's easier if I do 15y subtract 4y. Now, probably ideally you would want to then rewrite this with this equation here on the top and then do your subtraction. I haven't done that because I would have run out of space. So I've just written on the side, equation 4 subtract equation 3, and I'm going to do 15y subtract 4y, which will give me 11y. And then 95 subtract 62, which gives me 33. And now I can divide through by 11 to get y is equal to 3. And now I can do my substitution. Now in this case, it really doesn't matter which equation you choose to do your substitution into. I've gone for equation 1. So 5x add 2 lots of 3 is equal to 31. 2 lots of 3 is 6, so I'm going to subtract 6 from both sides. That gives me 5x equals 25. Divide by 5 gives me x equals 5. So my solution is x equals 5, y equals 3. Now, although we're not drawing the bars here, you should, or you could still be thinking at every step, well, this is what I would do with the bars. And that's really all we're doing. We're just not drawing out the bars, but you can still visualize the bars in your head, and that will tell you what it is that you're wanting to do with the formal method. So here is your task for today. There are two levels of work here. The first level, everything is presented with an X and a Y on the same side. And you've got to decide whether using difference, where your X signs are the same and your Y signs are the same, or if you're using cancel and sum, and that's where you'll have a difference in signs between either your X or your Y, or possibly both. Now, this second exercise here is a much more challenging exercise. You could use a different technique here, which is something called substitution, which is much more relevant for higher tier. So if you were presented with this on the foundation tier, you would want to rearrange your equation. So for example, this top one, so that you had y's and x's on the same side, a bit like we did when we were doing y equals mx plus c. And then from that point, you can go on to use the same method. Question 5 and question 6, it's saying find the coordinates of the point of intersection. So that is, you don't need to draw out the graph. You can solve these using the same algebraic method. But this exercise on the right-hand side is a lot trickier. So that is extension work for those of you that are finding this all absolutely fine.